Hey guys, it's Jess, and today we are going to work on graphing linear equations. Alright, so right here I have the completed graph, and as you see, this right here, these numbers are all positive, and so are these numbers right here. So that leaves this whole section of graph all positive points. Then on this side of the graph, on the left side, you have negative numbers ranging from negative, well, technically 0 right in the origin right there, all the way over to negative infinity. And as you guys know, infinity means forever. So this needs to actually be little arrows. Hold on. Okay, perfect. So then, as you know, it goes on to negative infinity. And then down here, is also negative. So it goes from -1 all the way down to negative infinity this way. And as you can see, it goes all the way up from positive infinity all the way up down to negative infinity, almost like a number line would be. So this especially is a number line because it goes horizontally. So it goes from negative infinity to the left all the way to positive infinity onto the right. So I hope that you guys have seen this type of graph before, because you will definitely use it a lot when you graph linear equations. So a definition that I sort of made up actually is an equation, usually in the form of mx plus b, or y equals mx plus b, that forms a straight line when graphed. So basically what that means is that when you graph this equation or any linear equation, it's going to form not particularly exactly this, but it's going to form a straight line like that has an even slope. Okay, and hopefully you guys know what slope is. But if not, I have a lesson on slope. But it has an even slope all the way across, and it also normally extends downwards too, like that. All right. So basically, we're going to first start with the equation y equals 2x plus 1. Now, this number 2, that would be considered our m, and then this right here, this 1 would be considered our b. Because remember, the form for a linear equation is y equals mx plus b. So this equation follows that exactly. So before you plot points on a graph, what I like to do and what a lot of other people like to do is use a table to find the points. So as you guys know, a single point on a graph consists of, there has been a little bit of a typo. I accidentally put a negative right there, but I did not mean to. So these are all positive on this side. I do not know why I did that. Those are all positive. Sorry. So if the point 2, then you would first start with 3, and then you would go up to 2. So your 3 would be your x, and your 2 would be your y. And this whole entire line is your x line. And then this whole entire line would be your y axis. So how I think of it is y is kind of like a long word. So that's like the long way. And x is kind of a little more fat. So it's like the goes across. That's how I think of it. So again, a point consists of x first, y second. So you move to the x way first, and then you move up or down according to the y. So basically, okay, so say we plug in a point for x. Normally I like to start with -3, and then I go down to -2, and then -1, and then 0, and then 1, and then 2, and then 3. So that's how I like to do it. You definitely do not have to do it that way if you don't want, but that's how I do. So your x can be whatever number you really want to plug in for x, because the only number that's going to change would be your y, because y equals this whole thing. So it doesn't matter what x is, but you have to make sure that you determine what y is based on the number that you plug in for x. So if you plug in -3 for x, then you're going to get an equation that looks like y is equal to 2 times -3 plus 1. Then you always would multiply these two together first, and then you would get y is equal to -6 plus 1, just like that, and then you would get y is equal to -5, because -6 plus 1 is -5. And we will go over adding and subtracting negative numbers in a later video, but just so you know, when you add from a negative, you're actually moving up the number line. So instead of being at -6, you would be at -5 after adding 1. So you go up to add. So -6 plus 1 would be -5. So then your answer for y would actually be -5. So you would plug -5 in right there. So your whole point would actually be -3, -5. So I hope that makes sense. All right, so because we have -3, -5 as a point, because we have an x and a y number, we're actually going to be able to point that on our graph that we made. So we first start with -3, because that's our x, and we always start on the x-intercept. We start at -3, and then the next number is -5. So then we go -3, and then we go down, and we find, one second, and we find -5. So we first went across to -3, and then we went down to -5. So this point is -3, -5. We went across, because that was our x, to -3, then down to -5, because that was our y. So -3 is our x, and that is our y. Alright, so let's go back to this side and then plug in -2. So now we're going to have y is equal to 2 times -2 plus 1. So we would first start with these, and we would do y is equal to -4, and then we would do plus 1. And -4 plus 1 is equal to -3. So then we would plug -3 in for y, because y is what all of this is equal to. So after we plug in x, and then we multiply it by 2, and then add 1, you get y. So that final answer would be -3. So we would plug that in for y. Okay, so now we're going to plug 30 in for x. So 2 times 3 equals 6. 6 plus 1 is equal to 7. So our next number is 7. Just like that. Alright, so after we did all that work, finding all those points, we get to finally plot them. We already plotted our -3, -5, and now we have to plot our -2, -3. So we'll go over to -2, and then we'll also find, so we'll go down to -2, and then find -3. I went a little too high, and then plot that right there. So -2, -3 looks like that. Then -1, -1, it's both -1s, so we plot that, and then we have 0, 1 is our next one, 0, 1 is our next one, and then our one after that would be 1, 3, So we'll go up 1 and then over 3. And then the one after that is 2, 5. 2, 5. 2, 5. And then the next one after that is 3, 7. So 3, oh shoot. 3, 7 right there. 3, 7. So we went across for x and then up for y, because 3 would be our x and 7 would be our y. So as you can see, I added a line for all of our points, and then I also kind of emphasized our points a little bit and made them a little bigger so they were a little bit easier to see. So as you can see, this line is straight. The only reason why there would be any curves in it would be just from my mistake of being a little bit squiggly while I did the line, but this line is as straight as a line could be. It is diagonal, yes, but it is still very, 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 very straight. All right, so if we go back to our definition of what linear means in math terms, it would be an equation usually in the form of y equals mx plus b. I should probably change that. So let's change that really fast. Usually in the form of y equals mx plus b that forms a straight line when graphed. So our equation was y equals 2x plus 1. So that would be mx plus b, 2 would be m, 1 would be b. So that's check. And this forms a straight line when it is graphed. So that would be check. So according to my calculations, this is a linear equation. Linear equation. A linear equation is when you have a graph. This is not focused. Come on. Sorry, this is not in focus. I don't know what's going on, but I'm going to sing the song still because I really want to sing it and I really don't care that it's not focused. Okay, so a linear equation is in the form of y equals mx plus b. Hopefully you can see that. It's really blurry. That's okay. All right, and it is always a straight line. It's so beautiful, and it has an equal slope the whole time. That means that rise over run, the rise over the run is equal to each other. So the rise would be 1. Actually, I'm not going to teach slope right now because that's a whole nother lesson, so we're going to do that later, but just know it has an equal slope and that it is a long line, and this isn't really a song, but that's okay. Linear equations follow the equation y equals mx plus b, and they form a long line when they are graphed. Make sure that you graph correctly because this is your x and this is your y, so make sure that you graph with your x being first and then your y up. So say your point was 3, 2, you would find 3, and then you would find 2, and then you would plot it, boom, 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 and then you would plot them all at the same time, and then you would put a line through them, and then if they're straight and they have the same slope all the way through and they follow the equation y equals mx plus b, then you know that they are linear. That the equation is linear.